My name is Tarun. As Tom mentioned, I had previously presented to the Tech Field Day delegates what seems like a long time ago. It was before COVID. But yeah, that was a long time ago. But I think I will bring COVID back into my presentation in a bit. So actually, so back when we presented, we were Banyan Security. We were a young company. We were a startup. We had just raised our first round of funding, and we were promoting some ideas that at the time were kind of controversial. But let me use a couple of slides to show you what those ideas were and then pull it back. So this is the slide Chirag just showed, which is kind of a typical distributed environment today. These are the kinds of customers SonicWall typically deals with. We call them distributed enterprises. Sometimes they are smaller businesses, but they oftentimes have a physical footprint in terms of headquarters and branches. But they also have remote workers who might be working from home, or they might be working from a coffee shop. They have contractors typically, and many times they outsource their IT and security function. So this is kind of a typical setup. When we started Banyan, this was not quite our worldview, but it was pretty similar. What we saw was when we spoke to our customers, we essentially saw the world broken up into the users on the left side and the applications on the right side. And what we had started seeing in 2019 is this kind of collection of security tools that were built one on top of the other, which in hindsight, looks pretty neat. But once you look at the connectivity from the user to the application, you see that it's kind of a ball of spaghetti. There's all this complex connectivity, either using a VPN or a firewall or a bastion and so on. And back in 2019, we had this exact same slide. So I don't know if it's still on the website, but if you go back and look, we were saying, hey, listen, if you have this kind of capability set and the type of user profile keeps changing, you have more and more remote workers, your operations are going to get really complicated. Managing policies across all these systems is hard. Your user experience is going to be bad because your users, when they're in the office, they have to do one thing. When they go home, they have to do something else. And worst of all, the security model breaks down. Now, I would say when we first presented, yeah, people kind of politely clapped. They were like, yeah, okay, we kind of get it. But then 2020 COVID hit. By 2021, this kind of idea of a distributed workforce or work from anywhere kind of workforce just became mainstream. And then the problem statement just became very relevant to many, many organizations. And I think the guys who really picked up on it was the threat actors. And the number of security breaches we saw after COVID hit, targeting kind of remote employees, anything from small businesses, but even big companies like Twilio and Okta, and all these guys started getting hacked using the very tools that they built. We really saw the security model breakdown. So the vision behind Banyan Security, which is now known as SonicWall Cloud Secure Edge, is that you can have a unifying layer that is really tightly connected to the user and the device they use. So that's really important to us. It's an identity-centric system as opposed to a network-centric system. So you can build an identity-centric system that connects user and device, whether they're in the office, whether they're remote, whether they're a contractor, to whatever resource they need to do their job. The resource could be on-premise, running in a data center. It could be running in a public cloud. It could be running a SaaS, or it could be on the internet. But regardless of where they are, use the same platform to provide this connectivity. That will simplify operations. The users will have a much better user experience using one tool, and the security model is improved. So this is a pitch from 6 or 7 years ago. And I would say first 2-3 years, it was very hard for the story. But after COVID, it just started making more and more sense. And so late last year, early this year, we had reached enough scale where it made sense for Banyan Security to join SonicWall, and we're now called SonicWall's Cloud Secure Edge division. Pretty much the same product, but all under the SonicWall umbrella, and we'll go into more details of how that works in a second. I just brought these two slides up. They'll still be in the SonicWall, in the Tech Field Day decks from back when. But the reason we started this company is we saw the shift. We saw the shift on the bottom axis is the shift to a hybrid workforce. You see that the first generation was complicated appliances. The second generation was kind of managed appliances still in POPs. And now a third generation product like CSC is essentially a cloud native version, really designed for this modern reality that we're facing. All right, with that, I'm going to jump ahead a little bit and kind of just talk about product capabilities and spend most of my time on a demonstration. So what product capabilities come with Cloud Secure Edge? So you see the user and device on the left side and the different types of resources. One core capability of the Cloud Secure Edge offering is what we call trust scoring. I will show that to you in a second, which is the idea that you can contextualize the risk associated with a given user and device. It's no longer a static decision. It is not just, hey, this is Tarun, he's accessing an application. It's Tarun on a trusted device that's running a firewall, that's in a home network, therefore he has a high level of trust, therefore he can access. So it's contextual trust. And the other one is every resource you're accessing has a risk and risk associated with it as well. An on-premise web application, low risk, you can go access it, but it has sensitive data. So we have to watch how you access the data. Something like CNN on the internet, medium risk. We still want to watch it. You might be downloading malware. Something like, maybe a gambling website, completely block it. So we have a good understanding of the application and resources, a comprehensive understanding. And then we have a set of tools. This is a buzzword soup. If you need network level connectivity, we have a VPN service. If you need application level connectivity, we call it zero trust network access or privilege access. If you need access to SaaS applications, we call it a cloud access security broker. And for internet websites, we call it a secure web gateway. So we've packaged all of this up into one solution, and that's called Cloud Secure Edge, which is the product I'm going to show you, with some two core principles, which is the days of having all of this packaged up and deployed in an appliance in your data center is kind of hard to pull off nowadays. Today, edge security needs to be enforced as close to the user, either in the cloud or on the device itself as possible. That's what guarantees performance. And the second is you need intelligence. You can't just have static policies. You need to take this context and do risk-based connectivity, risk-based threat protection. So that's kind of what the CSE product does. This is quite different than other vendors. If you look at other vendors in the market today, they're still kind of using, there are new vendors coming out, but the traditional big boy vendors are still kind of just using the old school technology, like cloudifying it a little bit. The SonicWall Cloud Secure Edge has been built from scratch for performance and user experience and really uses some of these intelligent concepts that I described. All right. So before I jump into the model, I just want to talk a little bit about when we say zero trust security, what we mean. So on the left-hand side, you have the user and device. On the right-hand side, you have all the different types of applications this user would need to access. So there are three core components to our zero trust security model. We have an app that gets installed on your devices. We also support clientless scenarios. So if in the clientless scenario, your browser is the client. But the app allows us to posture a device, set up the connectivity. We have a dynamic cloud edge. You basically would connect to the locations closest to you. They're running in the cloud. It's dynamic in the sense if you move, it kind of moves with you. And then we have a command center. This is a SaaS console where the administrators write their own policies, define what a user can access, and so forth. So anytime a user tries to access a resource, when we say zero trust, we mean there needs to be explicit access approval. So the request gets sent to the SaaS console where risk is evaluated, where a routing decision is made, and behind the scenes, a user's attributes and device posture is calculated. So we integrate with identity providers like Okta or Entra ID. We integrate with device managers, device security providers like CrowdStrike or AirWatch and so forth. And we're able to figure out, hey, what exactly is this device and user trying to do? Based on that, we issue a short-lived credential that grants access to that resource. We also have an inventory of all the services, all the applications that a user needs to access, and all the different threats out there in the world. So when something malicious happens, so for example, if you install malware on your laptop or you're trying to access a resource that you shouldn't, in real time, we revoke that access as well. And I will be demoing all of this in a second. All right. So with that, I'll jump into the demo. Any questions or comments before I proceed?
Just maybe a quick one from my end. So, you've mentioned, in general, other companies that might, that do stuff in a traditional way. One of the first thing that, comes to mind when you see something like that would be, so how redundant it is in terms of, access. Other companies had outages.
Yes.
During COVID, it was, a great example for, yes, everyone is making the shift, but still, is it resilient enough to actually handle, something that is now going to cause many businesses to fail?
Yes. Yeah, that's a great question. And it's not just during COVID. I mean, I think about 3 months ago, CrowdStrike had this outage that basically grounded airlines. And
but within the angle of, that shift you were referring to, and now,
yes.
so many businesses are relying on remote and hybrid workers.
Yeah.
I mean, obviously, CrowdStrike incident is an interesting one, but it's completely, different scenario.
Agreed. Yeah. No, I was just saying, more and more businesses are reliant on software that is managed remotely or is running in a completely different environment. That something completely unrelated to the business can bring the whole business down. All these airlines stopped flying because some antivirus or endpoint security software stopped working correctly. And that is unfortunately true of any cloud-based software.
Well, to be fair, okay, and I'm definitely not representing CrowdStrike, in this conversation, but their incident, obviously, because of that how well integrated this product is part of the Windows OS.
Yes.
So yes, when something fails, during boot, yes, it's not going to load. And I'm talking strictly about access.
Yes.
Right, trying to consume a service.
Yes. Yeah, and for us, something similar. Like if we fail, you can't access your resources to do your job. And that is catastrophic for many businesses, completely unrelated to security.
Right.
So you're right, the analogy is limited, but the same kind of impact. If we go down, you can't access, say, that Salesforce instance that you need to do your sales job. Or if we serve several healthcare companies, you can't upload electronic health records. You can't download the imaging that you need to do to make a diagnosis. So we spend a lot of time thinking about availability. We do have outages. I would be lying if I said we don't. But we're very careful. We have a lot of redundancy. We're using multiple regions around the world. We ourselves have tight processes that we follow. And the key thing I'd say is when we have outages, we try to learn from them and we keep them very small. And so in our history, we have had, I think, maybe one outage that I would say is significant. But typically, we've had smaller ones that we learn from and we don't repeat. But the advantage of being in the cloud is that you can constantly iterate, you can constantly add new products, add new features. But the one downside is, you are dependent. And we give you an SLA, 4 to 5 nines, and we work very hard to keep that SLA, and we have commercial terms in our contracts about that SLA. But from a technical perspective, you're absolutely right. It is a challenge.
And Okta was another good example.
Great example.
For what can happen.
Yeah, absolutely. Yeah.
I have a couple of questions about this slide and the one that right before it. If I'm understanding it right, because a lot of the products in this space that kind of grew more out of the cloud native product vendor pedigree did the whole tunnel cloud routed architecture where you routed through something.
Mm-hmm.
And then the resource you were accessing also stitched a tunnel, basically the same thing.
Yes.
And so you didn't really have control over the data path, which made it really impractical for organizations that had on-prem to on-prem, access models. So it looks like from this and from the previous slide, what you're doing is a cloud coordinated but direct routed data path.
Oh, wow. That's a great question. Actually, I have it in my next slide, which I was going to skip. But I think the answer is to that question is we actually have both options.
Okay.
So we have a global edge. And our global edge is running in our infrastructure providers, Google and Amazon. So we have a low-cost networking model that allows us to use their global backbone, right? So
your POPs are public.
So our POPs are actually distributed within these guys. So we have POPs here, and exactly what you described, which is to connect to our global edge, a customer would deploy a connector. And by the way, in the next slide, that connector is built into every SonicWall firewall now. So your SonicWall firewall can just connect into our global edge. And depending on which part of the world you're in, where your infrastructure is in, you will connect to different global edge POPs, and your users will connect to different global edge POPs as well. Now, one key capability in the CSC product is we have a concept called the private edge as well. So if you need, as you mentioned, data center to data center connectivity or branch to data center connectivity, and you have an existing lease line, for example, that you're already paying for, we have the concept of a private edge deployment model. And the private edge deployment model is essentially you can have your own point of presence in your model. And when I say cloud native, what I mean is that private edge is just a Golang binary or a Docker container. So you can install it on a Windows server, you can install it on a Linux machine. It's actually built into our firewalls because it was so easy. So it is really a very lightweight component that does enforcement that connects back to the cloud. And so we allow both models. That's where we feel like we're the next generation, because in the second generation, everything had to go through the point of presence, which is fine. It was quite effective. But if it's truly a cloud native, then most people run their own clouds nowadays, either in AWS or VMware cluster in their data center. And so if it's truly cloud native, hey, if you want private access, you should be able to run it yourself. And that's the model we espouse with our private edge.
Just to be clear, that private edge, is that running the CASB, the Secure Web Gateway, and so on?
The private edge, this private edge that I'm drawing here, is for private access. So it's running a proxy, but it's used for zero trust network access, privilege access, and VPN. So typically, if you want to go to internet resources, which I'll cover in the next slide, you typically just, if you're going to an internet resource, you'd rather just use RPOPs, because RPOPs are already kind of globally located. And then if you're going to connect to a SaaS application like Salesforce or Microsoft 365 or Netflix or something like that, you want to use our global presence. Typically, it doesn't make sense backhauling it through yours. So we do break these two capabilities out. The private edge is used for private access, while our global edge is always used for internet.
And also, I just wanted to ask a question about, you've got an app that runs on a user's endpoint, but you're also supporting like CrowdStrike or other EDRs. I'm curious, what is the functional overlap between where you have
Let's jump into the demo itself. Let me just go and show it to you in action. So the question was, hey, a little bit about the app, how does it integrate, what does it do? So let me just, I'm just kind of mimicking an end user right now. So I'm an end user, I have a laptop. Most of the time, you don't even see the app for a client-based mode. It's just running kind of quietly in the background. And let me just open it up for you to bring it up. So I'm not even logged in right now. So the app is running in the background all the time. But what it is doing is it attests to the device. We attest to the device cryptographically by putting a device certificate, in my case, in the user certificate store attached to the trusted performance module. So it's a strong cryptographic trust with the device. And then we're also scoring the device. In my current setup, I'm using pretty simple scoring. You'll see that for my demo environment, I've turned off auto update, but I have turned on the right version, disk encryption, firewall. So we're monitoring these factors in real time. And so my trust level in this demo environment is considered high. When I move through the demo, I'll show you some more trust factors. One of the trust factors we can bring in is CrowdStrike running on the device? What is CrowdStrike saying on the device? Is SentinelOne running on the device? Is the device compromised? We have tons and tons of trust factors. For the purposes of the demo, I'm going to have the ability to even lower my trust factor, manipulate the trust factor, so I kept it small and simple. But the user essentially gets a score, and the score is a dynamic score that changes based on the context of the device. And again, by default, it's doing nothing. It's kind of quiet. Let me just authenticate with my system. So by default, the Cloud Secure Edge is integrated with your identity provider. I'm using Okta, but Microsoft Entra is a very popular identity provider. But the idea is that we don't try to do identity ourselves. We're going to integrate with your single sign-on, your MFA tooling. And once you're authenticated, you're kind of just magically connected to whatever resources you need. You'll see if a user was interested, they could open the app. You'll see that we've set up a tunnel if you need network layer connectivity, for example, to access Windows workstations or servers. We bring up a catalog of the different applications. We're more an application layer connectivity solution. So if you have websites that can be accessed over the browser, you'll see it. If you have Windows servers or databases and so on, you'll see all of that as well.
Are these tied on the back end to like group?
Exactly.
Directory structure or something?
Exactly. Yeah, I'll come to the admin console. But the resources that are surfaced to you as an end user are surfaced via policy. Policy is typically written in terms of these groups of users can access these applications. And the groups are just imbibed from the identity provider. So Active Directory groups, Okta groups, something like that. We don't have our own groups. But the general gist of it is, okay, once you're set up, once your client is installed, you don't have to deal with that. The other thing I just want to point out is that our session duration, I put it up here specifically, can be anything as short as 1 hour, which is required for some compliance environments. If you're connecting to a production environment, they want you to auto disconnect. But then some of our gaming customers want long sessions because their developers are just uploading and downloading games. And so you can customize the session of the app, the session to, say, 1 week. I wouldn't recommend that. But because of our security model, you're able to customize the session independent of the single sign-on.
So based on the app they're accessing, not just...
Based on the user profile.
Based on the user profile.
Based on the user profile, yeah.
Okay.
All right. So now as a user, okay, I'm connected. Now what does it look like? So let me just try to access some internal website. So this is a Oh, I was kind of boring, but anyway, the idea is that it's kind of seamless access. Let me open an incognito tab to show you kind of what happens behind the scenes. So behind the scenes, what you would have to do to make a connectivity like this is we are connecting with our identity provider. We are in real time evaluating the device posture and then granting access. The user doesn't see all this. The user just types the URL. A URL could be some website. This website is deep inside the organization. It's like a medical trial, some CMS running on WordPress. They don't care. They just enter the URL, they access it. And they access, it's the same way as they might access a Salesforce instance. Again, there's no difference. All of this is going through the security stack that is, again, I'll open it up incognito so you can see what happens. So in order to access Salesforce, for example, again, same step, you have to go through a single sign-on. You have to enter your, then that takes you to Salesforce. You have to enter your username, password, and then you get it. So my point of showing this is that it doesn't matter whether it's a SaaS application, doesn't matter if it's an internal website. I'm also going to launch just a kind of a Windows RDP session. This is a remote connection into some Windows server running deep in my data center. All of that stuff just works seamlessly. The user doesn't need to think about what network they're on. Yeah.
I just noticed that you had to re-authenticate for each app.
You don't. I was opening an incognito browser to show that I had to re-authenticate.
Gotcha.
But if I was in the same, it was kind of boring. I just opened it, it connected. You're like, what the hell's going on? So
Good.
I just wanted to prove to you that there was an authentication step, but it's just kind of transparent to the user.
Okay.
Yeah.
And you've anticipated users trying to get around that app by opening another browser and trying to see if they can.
Yeah, one of the things in our space is a lot of people have tied a security model to a browser. Like they'll put a Chrome extension on the browser or they'll tie it to the browser, which is fine. It's good for productivity. But for security, it's kind of weak because you can open another browser. You can download a different type of browser. And personally, I run so many profiles within a given browser. I run 10, 15 profiles. So a security model tied to the device, make sure that you can't bypass those controls. Yeah.
And that's, I think you said earlier, it's tied to the TPM chip. So it's
the certificate is in the user keychain,
Yeah.
which if the TPM chip is there, it's associated with that. On Mac, they use some other concept. But
so it's your authorized machine, not a personal device.
Exactly. Registering the device attests to the device. And for our large organizations, they have device managers, and the device manager will ensure that the app is distributed seamlessly as well. It's a very powerful way to do it. Chirag, how much time do I have left? 5 minutes. Okay. So let me just speed through this a little bit. So I was kind of showing the end user experience. So let me just switch to the admin experience. So I'm just switching to the admin console now. So from an admin perspective, so I've provisioned this to all my users. Now this is quite different than a kind of a traditional way to see the world. It's more like looking at it through the lens of an identity provider, which is we tell you all the devices, all the users that are in your system. Because we have this application layer visibility, we can start telling you about the different applications, my websites, my workstations. And we love this little chart that tells you, hey, these are the kinds of devices. This is a level of trust of these users and devices, and this is what's accessing things. I'm going to block attempts in a second as part of my demo. And you can also tell you why things are blocked very quickly. One of the things I was talking about was trust. How do we set up trust? Trust is really dependent on the types of users and devices. You'll see here in my setup, a kiosk has a different level of trust from a developer, from a Chromebook, from a tablet, from a contractor. So you can create very granular profiles of what you mean by trust in your organization. You can choose between, factors that include CrowdStrike, SentinelOne. We have a bunch of native factors built in based on whether the device is jailbroken, if a file is running, what the registry look like. So this is a very sophisticated way to trust devices.
That's like clean canvas when you start building it, or you can have some templates.
Yeah, so we do have templates. When you create a profile, you can create a trust profile from scratch, or you can copy a profile that you have previously created. We provide some default profiles for you. You can copy those, and you can start from scratch and do your own. The other thing I just wanted to show you quickly is we talked about the network. We call that our access tiers. We provide you a default set of points of presence. You'll see this organization has 7 or 8 distributed across US East and US West. But you can add your own. So I've added my own data center point of presence in GCP. And then the last thing is this is a real-time system. Since we YOLO, I'm doing all these events live. So let me just go and event type. Let me just filter by my user. So if I filter by my user, you'll see the stuff that I've been doing. I did access Salesforce. You saw that. I was authorized access. I accessed the trials platform. Now, one of the key things I just want to switch back to user thing is we're an application layer system. So even though I can access this website, I can say, me as a user, I'm not allowed to administer the website. So I can block off the administrative section of portals. Similarly, with Salesforce, a common concern in Salesforce oftentimes is folks who need to, hey, you can see the file, but I don't want you downloading files and things like that. So within Salesforce, we can also block things like, hey, we won't let you download files. So we can add these controls that ensure that high-risk assets are protected sufficiently. And I did that. And so in real time, hopefully, if I refresh it, maybe it takes a little longer, but you'll start, there you see, you start seeing deny events. So as soon as I start doing unauthorized activity, you'll start seeing deny events. And in the next demo that I do, I'll show how we feed that into a SIM and the SOC can take action on that and so forth.
You know when somebody's trying to, I mean, that's a nice, easy way to see somebody's trying to access something.
Yes. But this might actually be legitimate. They might have just clicked on a wrong link.
Yeah.
Sometimes they do illegitimate stuff, and that's the tricky one.
Can we ask about I saw PAM listed. Is PAM just kind of like, oh, you can use it for that too? Or do you feel like you guys have invested in additional set of features for privileged access management?
I think we've invested in enough features to be reasonable in the privileged access management we solve, but there are some very high compliance environments that we don't target, that there are other players who do a good job. But we do enough PAM for the businesses that SonicWall targets where we're sufficient. I just want to show one final capability, which is around internet access. We spoke a lot about access to private resources, applications that you control. A lot of the time we spend is just kind of surfing the internet, And so one thing the product does is starts discovering the applications you're using. In our environment, a lot of Microsoft, a lot of Okta. I'm an admin, so I'm adminning Dropbox and SAP and so on. And then you can start writing internet threat protection policies. So the policies are written in terms of, hey, I want to block certain bad types of internet websites like phishing websites or very new domains. I want to filter certain types of content. For this demo, I'm filtering dating websites and also filtering like TikTok because I don't want you guys to use that. You can filter specific apps. I don't want you to use WhatsApp. And you can assign these to specific devices. So the same client, the same product that is managing your private access is also taking care of your internet access. And so if I were to try to go, I'm opening incognito browser because that's the easiest way to show it. If I were to go to a website like, say, TikTok, for example, you see that now that policy is kind of automatically applied and access is being blocked. And similarly, I don't know what the kids use nowadays, but back in the day, it was Match.com, I think. I don't want to pry too much. But, we're blocking. I hope the categorization system is good enough where it blocks what the kids are using nowadays also. You can put these acceptable use policies across your entire organization.
So the reason you're able to do this kind of enforcement is because the connection is going from the endpoint into one of your POPs where you're applying security controls?
So again, we're being a little bit more sophisticated than that. So we separate out DNS traffic from internet traffic from private access traffic. So private access traffic will either go direct to your data center or go through our POPs. Internet traffic will go through our POPs unless it's low risk, like Netflix, Chase.com, they will go direct. And this particular one, Reddit and TikTok, these are high risk, so they come to us and then we block them.
So I'm sorry, I didn't mean to interrupt. So if it's the low risk ones that they're just going to drop off and it won't go through those POPs.
Yeah.
The traffic or whatever, sites or apps, things of that nature you're trying to access, is it going to be defined similar to almost, I don't know, however you filter it based by content or malicious sites, things of that nature. Does it filter it by that in range before it sends that?
Yeah, the intelligent routing we're very proud of it, so I could spend a lot of hours, but that's roughly how it works.
Okay.
It's roughly how it works. We have a default set. It's in our console, and then you can go adjust the default.
Okay, I figure. So you can tweak and create your own policies. Okay, cool.
And for internet and SaaS apps that are hitting your POP, are you breaking TLS to do like payload inspection?
So you can choose. We can do it at the DNS level, in which case you're not breaking TLS. Mm-hmm. But if you choose to do URL filtering, then we have to man in the middle of the traffic. Yeah.
So I'm curious, with the private stuff, one of the things I've seen in a lot of the similar applications is everything works great for SaaS, web apps, all that stuff. And then it falls over when you find out that the accountants are using a ginormous Excel document on a SMB share somewhere.
Yeah.
Do you guys have anything to help with those types of scenarios? Because it seems like a lot of the players in this space can't account for that chattiness of SMB. And then,
So that's why we have a full tunnel that's built on WireGuard. So I started showing you a Windows file share here. So because we're using WireGuard for that private access, it's very high performance.
okay,
And one of our largest customers does radiology over our tunnels, which are these huge. I had no idea. These are gigabyte images. During COVID, many radiologists started working from home.
Yep.
And so we were able to enable that kind of workflow, large file workflow.
okay, cool.
Yeah. In the interest of time, I'm not going to go into the demos where I break things, but if I get a chance to come back, I will come in and install some malware on my laptop and see what happens. But these offerings are now public. We have a private access offering and an internet access offering. And I think the one thing to segue to Chirag is everything is built into the firewalls now. So if you have a SonicWall firewall, you just kind of, on the right-hand side is this console, you click a button, it sets up an outbound tunnel into our POPs. So everything behind the firewall can now be exposed using the CSC platform.